Yeah, this is October 1st. We have a lot of people out. So any of you guys at home, please feel better, get unbroken, whatever you need to do. So, as Ike just reminded us, Ike, how much do we grow each year?
4 feet.
4 feet each year. And we also found something out about when we planted it. What did we find out about when we planted it, Logan?
Just to help us catch up, can you say we're mustard instead of master?
What? No. That's really, really, really bad. That's like worse than even the jokes I make. No. Logan, I didn't know you had kids. I didn't know you had children at home, because to make a joke that bad, you gotta be a dad.
Well, wait, is it that bad? To make a joke that bad, you have to be a dad.
Logan does not have children. The joke is like when you become a dad, you make really bad jokes because you like have no sense of humor. So that was a definite dad joke. Thank you, Logan. But for real, Logan, do you remember how tall the tree was the year it was planted? You should have it on your resource page from yesterday. Get your resource page out. So that's issue number 1, because it was on the start slide that we needed our resource page out. Josh? 5 feet in year 1. So as we go deeper into math, we will use tech applications to help us with these things. We need to know where it starts. We need to know where it goes.
Year 1 or year 0?
Oh yeah, year 0. Sorry.
Why is your mouse having a seizure?
Okay, so again, off-topic questions. It does that when the recording software is going. Don't ask me why, but that's what's happening. So we had set up an equation, right? And if I cheat a tiny bit and just go back to what we did yesterday,
What?
here's our equation,
What?
right? So we had the height will be, and you might want to write this down again if you don't have it right in front of you, the height will be 4 times t plus 5. How we're going to use this is when we're given an amount of time. I'm going to start charging you for pencils, because I saw you get a pencil, sharpen it, and take it this morning. So my question is, what happened to that pencil? We have discussed really briefly input and output data, or independent and dependent. I think you're doing this in science a little bit. Patrick, you got a comment? And yeah, through its whole lifespan, most trees will grow pretty consistently through their lifespan. Certain trees will grow out, other trees will grow up, right? So redwood trees, they are tall, like the redwood forests, hundreds of feet tall. Sunlight can't even get to the ground. It's pretty amazing.
Oh, so cool. But even the trunks are like this wide around. I had my whole family try and hold hands around this huge tree. We couldn't. And my dad's 6 feet tall.
Yep. So redwoods grow up, but the trunk grows, keeps getting bigger because it has to support the tree. There's a redwood that you can drive your car through.
Yeah.
They have cut a tunnel through the tree. You can drive your car through a tree.
Sadly, though, it's kind of stupid because they just killed the biggest redwood, and then slowly it'll die. So.
I think it already had a disease or something. So I agree with what you're saying, but you're saying a lot about something that none of us in here are experts on. You know what I mean? So I'm sure they had a good reason. You don't know that. I'm sure they had a good reason to, in a national forest, deface a tree. Right? I'm sure they had a reason. But moving on, when we have XY situations, graphable situations, not laughable, graphable, X is the independent variable, Y is dependent. So Y is our dependent, X is our independent, which means the output value, or the result, relies on us knowing an input or some piece of data that we go in. Right here, our input is age. So when we set this up, we have h of 4 times 50 plus 5. What's 4 times 50?
205 feet.
Well, close, 200. And then when we add the 5, except the question asked was what was 4 times 50, so the number you shouted out was not. Any questions on how we use an input value for our X and an output value? And we're going to reformalize stuff we talked about yesterday. Any issues with John's tree right now?
Is there like a formal abbreviation for dependent and independent?
What do you mean, like what you could write?
Yeah, because when you wrote Depp in, I thought of Johnny Depp and then Indiana Jones. It just made me feel very wrong.
Happy? Oh, I would be happy if I was thinking of Johnny Depp and Indiana Jones.
I don't know, just the two of them.
No, I don't know who would win if they ended up fighting against each other. Just as I throw screens back and forth, if it's not on the top screen, it's probably on the bottom screen. So, how that looks when we get to graphing. And guys, some of today is just kind of like watching and having your brain turned on. So please respect that. We have this table, and we could actually just drag points to where they belong. So if I drag my point of 317, that's 12, 14, 16, 17, 421, 525, you can if you want, but like I just said, I really just need you with me, engaged, listening. What do we notice here? It's a straight line. This is what we call, and what we're going to write down, yeah, because you're down there, a linear function. So this is where we start to formalize some new vocab of functions. So this makes a straight line. And that tells us that it is a linear function. Which means that, like we talked about yesterday, it can be formalized in the form of, I don't really like that, why?
I always read it like my x, except I added more of a 2.
And guys, you totally need to label these. I have some people that be like, oh, I'll remember those. And 2 hours from now or 2 days from now, you will not. Y is our dependent variable. We normally don't know y to plug it in. Sometimes we do, but when we know y, we won't know our x normally. B is our intercept, or really what we can call our start point, and it's our y-intercept. But when we talked actually about slope-intercept form, right, that was written on the top of the last slide. So our y-intercept, and it's not intersect, S-E-C-T, although it does intersect the line, it is called our y-intercept, with a P-T. X is our independent variable, or our input. And really the most important piece here, that M, what in the world is that?
Mastery.
Alina? It's the slope. What else? Is like, how do we, beyond what it's just called, do you know how we find it or how we know what it is? Not just y. You're right, but it's not just y.
It's y minus something.
It's the ooh, yeah, you totally know what it is. I'm writing the easy way first. You're thinking of the harder, like that. You're what Alina's thinking of. I can't believe you know this.
Well, it's on Khan Academy.
Ah, that's totally why you know this. Y2 minus y1. Does that sound familiar? What's on the bottom? X2 minus x1. That is your change in y, which in math we literally use the triangle, which is the Greek symbol delta. So when we say delta y, we mean the change in y. We use delta for a lot of things. Science, physics, like we use delta all over the place. It's the change in y over the change in x. So when we have a few points, we can figure out the change in y over the change in x. So please make sure we have this written down. I'm going to give you another second to get it down. And then look down on the TV. We've got these. We've got 3 points really, but I'm going to forget about the middle point for a minute. And for those of you playing along at home, we'll put this here for a minute. So we have this point, 317. and 525. Draw like an arrow, and I'll show you what I mean up here, showing that 317 turns into 525. Y2 minus Y1, X2 minus X1. But you don't need all of that. Really, all you need is the delta Y over the delta X. Because we're about to practice. Yes. $317 goes up to 525, and they make a line. Now, regardless of if they make a line or not, I could still look for the slope. Hazel?
What else did you call the exercise independent?
That's what we called it. Yeah, I can come back to here for anyone that is worried that you missed something. X is the independent variable, and then I just drew a line separating the slope stuff. If you want another way to call it, it's also the input. The input or out, like Y then would be called our output. If we call the X the input, the Y is the output. So if we wanted to find our slope using Alina's method, we have to figure out, well, what is X1, X2, Y1, Y2, that sort of stuff. It doesn't actually matter. I could make this point, oh, that's a 1. I could make this X2, Y2, and this X1, Y1. It doesn't matter, but I will tell you the easier way is make the 2's have the bigger values. Logan? Just can't hear you with the fan. Sorry.
Okay, so would we really want to use the 1, the 2 underneath it? Because that could be confused for longer.
That's a sub, so that's like X sub 1, so it's subscript. That's what we use. So again, we're not doing logarithms right now, right? So get your brain out of that branch. Be with us. Be present in this moment. Have I said the word logarithm ever this year?
What's a logarithm?
I mean, now, yes. Right now I have, because I just said it like 4 times. But we're not doing logarithms. So what Logan again is asking is math you're not supposed to understand, and I'm not going to talk about. So there's no other way for us to write that. There's no other way for us to write that. That is how we write the X1, Y1. Like, we just use subscripts. I'm sorry. Like, I know what you're saying, but it's a different branch of math. Like, we know in this branch of math, those subscripts have nothing to do with logarithms. Over here, sure, you know that they do, but we're not there, right? It's like you're talking about like Florida laws, and we're up here in Ohio. Like differences, right? There are differences. People in Florida are crazy. Yeah.
What was the next other slide? So
Yep.
people in Hawaii are banning certain beaches because there was.
So linear function, y equals mx plus b. So this x in there and that y in there, those are points on your graph. But if you only have one and you plug it in, you still don't know your m and you still don't know your b. What we're about to do is, and guys, so you know, I am over teaching a little bit. Like, I'm showing you stuff that you'll need to know later on this year, so you start to have some exposure to it now. So my y2 minus y1, if I want to set this up formally, I would write 25 minus 17 over 5 minus 3. Or, once we get good at this, how far is it from 17 to 25? 8. How far is it from 3 to 5?
It's like 2x.
Wait, so that's division now, right? It's you're dividing.
Yes, but it's easier when it's like this.
I don't know what just happened, but
It's exactly what we figured out before.
wait. So
It's 4 feet per year. This is what we already figured out from your table. But this is a method that always works and is often shorter, quicker, and uses the calculator. Right? So we can just do that. I'm not looking for the explosive reactions. I'm just trying to give you the easy way. That's our m. So we now know y equals 4m plus b. Now, crap. We still don't know the b value. Sorry, that should be 4x. I don't know why I wrote 4m. That 4 is our m. because it's our slope. Liam?
So you took the smallest value in the information that we already knew, and then the greatest value of the information that was given to us.
X goes to X, Y goes to Y. Okay, so don't get yourself hung up on small, big, whatever. You just have to go the same direction. So think about it the other direction. Ignore this if you need to ignore this. But to go from 25 and get to 17 is a drop of 8. And to go from 5 to get to 3 is a drop of 2. Negative divided by negative equals positive. So that's what I meant by it doesn't matter which order you go, you just have to make them both go the same way.
So if you did it the opposite way, you would have, what would you have if you made that side 1 and that side 2?
Exactly what I just showed you, negative 8 over negative 2. It comes out the same. Here's the other thing that we're doing, and this might really help you guys. Slope, or that m value, is nicknamed in the easiest way to talk about what slope is. Rise over run. Please write that down because that is the easiest way. How much did we go up or down? By how much did we go left or right? Now, that's inferring that you will think about down is negative, right? So if our line is going down, our slope should be negative. If our line is going up, like we see here, it's going to be positive, right? Just kind of use your intuition of is that positive or is that negative? So we have, probably way over teaching. Why? What's confusing you?
I don't know.
Well, then I don't know if you're confused. I think you're just still like ingesting the new information. That slope tells me what to do to get from one point to the next. It says go up 4 when I go over 1. And notice our scales are different here. This scale goes by 2. This scale goes by like a quarter. So it also tells me how to find new points. From this point of 5 to this point of 6, I need to go up by 4. Boom. Or to go from 3 down to 2, what should I do with my rise, Avi? Minus 4. So from here, 1, 2, 3, 4, boom. 1, 2, 3, 4, boom. And 1, 2, 3, 4, boom. That's our linear function, all showing out. Does that mean what?
Wait, does that mean our B is 4?
It's 5, I believe, because this is 9.
Yes.
That's 1, 9. This is 0, 5.
So how is that over teaching?
Minus 12.
Well, what I'm debating on, if we're about to do, is then derive how do we get the B value. All right, you don't need to know this yet. Well, let me show you one more thing. If you just hang on to it for just a second. If you have y equals 4x plus b, like we had on that last slide, and you don't know what b is, I mean, we do know what b is now, right? It's 5. We just talked about that. But if we don't know what it is, what we want to do is use one of the points that we know exists. 317, 421, or 525. Those were all given to us, right? So I used 317, the first point that was given to us. 17 was the y value. 3 was the x value. B is whatever it needs to be to make this true. What's 4 times 3?
12.
What does 12 need with it to make 17? B has to be 5.
What?
So that's also how we can derive the B. Yep.
Well, B is the y-intercept.
Yep. Yeah.
The y-intercept is just where y and the x-axis, but no.
When x is 0.
Yeah.
Yep.
How do you figure that out?
So you didn't hear, this is why I said I'm over teaching. If you were in a situation where you knew the slope and you had some points, but let's say they're really far away from the y-axis, you can just plug them in and get your b through algebra, right? We can just do the math. Here, we already knew what b was. I was just showing you if.
Hey,
I
need to know this yet?
want correct.
Okay.
I overteach. It is like my hobby.
My dad right now.
You what?
You're acting like my dad right now.
Is that a bad thing? Not necessarily. All right. Do we think we could figure out the height of the tree in the 0, 1st, 2nd, and 6th? Yeah, we already did it, right? We already did that. So that's why we're going to start our next lesson, and then like we'll pause at some point and give you some time to work on homework and whatever. Logan?
So a good way to like visualize this graph is to think of just kind of maybe draw like trees going up and then up the slope.
Oh yeah, like this tree was after 1 year, this tree was after 2 years.
Yeah, basically think about it and then make them as high. Put them on the like the
X-axis.
and then grow up and have their height.
Love it. All right, so draw squiggly across your graph paper. You don't need a new graph paper out because remember it's notes. Draw squiggly.
I actually put all my notes on here. Is that okay?
I mean, sure. Just make sure you keep that. You don't need to write this whole header. You could just write identifying solutions, or you could write like graph calc work, or graph calc sol. What is even 2 math? I'm not math. Am I math now?
No. Read it out loud.
Oh, no, I'm sad. Dear Matt, please stop making me find your ex. She's never coming back to you. Love your friend 21. All right, so 21. In the last 2 lessons, we've just been determining patterns, right? So if you're not a fan of patterns, you've probably just been like, okay, when are we going to get out of this? Well, not yet, sorry. So more patterns. If we look at different algebra figures. Yes, you are correct. It doesn't seem to look right. So let's go over to the E tool. Oh, there we go.
That looks
Slightly better. Right, so we can see, like, I don't know if you can see from back there. Actually, I shouldn't assume. There are 4 boxes connected by 1 box to 4 other boxes. So go ahead and sketch that on your paper real quick. Actually, did I put this on your yellow sheet? I have some stuff on this yellow sheet.
I feel like this is I can already see it.
Oh, no, I don't. Not this one. Sorry, I lied to you. That's also, this is,
Again?
so this whole paper is your homework, which is also why this is a 2-day lesson. This is a 2-day homework.
So, wait, we do math. So we have tonight, and tomorrow we have to do this homework, and
It is a 2-day homework. It is a 2-day lesson.
You said something about 4 boxes.
Oh, that image. I don't know if you guys from way back there can see. There. Stop. It's the top is 4 boxes connected by 1 box to 4 boxes on the bottom. And I may flip screens and draw this with you guys.
wait, so then
I
figure
don't know if I can zoom out.
4 would be,
Hold on. So this may be easier to see
this one is
if I drag it.
for me anyway. Wait, whoa.
All right, so now you might be able to see it a little bit easier, and I can draw on top of it. So
It's-
4 boxes, 1 box, 4 box. I will take your question in a moment. It just can't be right now. And then over here, it's 6 boxes, right? A 2 by 3. This is 3 connecting it. Why do you keep talking at the same time as me, gentlemen? Why is this not drawn on your paper? Like a 2 by 2, kind of, but this is only 1 in between. What will figure 0 So you still need figure 3. Right, so figure 3 is a 2 by 4 connected by, anybody have predictions? 5. Can you formalize this in the form that we were just doing, slope-intercept, in some sort of y equals mx plus b, where x is your figure number? Why? I don't know why that does that. Where x is your figure number, and y is the amount of tiles needed. Yes, it is frustrating. So this is your x. So, like, how many tiles are in figure 1?
5. No, 9.
9. Please think before you answer. How many tiles are in figure 3? 15. So that's your y value. Right here, y is 15. X is 2. How many tiles are down here? 28. Is it 21? I cannot escape it.
So my question was, can you, the one with all the dots on it, can you like move it on the tool to the next one? Is that why there are dots on it?
Yeah, that's why it's all crowded with dots. Alex, what do you notice? Don't like give me the final answer, but what do you notice?
No, okay, I'm sorry, I wasn't prepared for that. Can you scroll just for a second?
Oh, yeah.
Alright, so if that's 9, 15, so that means it's at 6 each time.
Adding 6 every time, right? So Alex has figured out what our slope is, right? We're adding 6 every time, but we would still need to know our figure 0, how many tiles that starts with for that intercept. And, well, we have to be able to make it, right? Not just know how many tiles there are, but we have to be able to make it. Elena, what are you feeling?
Okay, so what I'm thinking for the first part of it is we multiply. Well, what number are we? What figure are we trying to do? 4?
I'm trying to make figure 4, but know what it looks like too.
Okay. So for the number of tiles, you have to figure. You have to because of our slope being 6, we have to multiply 4 by 6, and then basically.
Ooh, we need to know what other numbers involved. So hold on, let's see if we can figure out what this looks like first. So we know it would add 6 more tiles, but how? What does this look like? Jacob? Yeah? Jacob? Yeah. Josh, dang it. I'm like, J name. What? This is what happens after 8 years of kids' names getting jumped up or jumbled up in your head. Sorry, Josh. 7 in the middle. Okay, can you give me the top part first? Because I don't quite know how this thing works.
2 times 5.
So, to take away one of these. Okay.
Whoa, that's fancy.
And then I got to drag these in.
Makes no sense.
It's just like cloning. So when they stack, they get darker. So if I don't fight, the E-tool is going to take a while. If I just like make a sketch of it, describe what the sketch would look like.
So the shape to the left, the middle is 5, but you'll add 1 on each end, which would make 7. But
Okay.
the 2s stay the same, and then you add 2 to each of the other rectangles on each side, and then you get 27.
So you had said it's a 2 by 5 up top, like back when I was fighting with the E-tool. It's the same on bottom, right? So that's a 2 by 5, and we have 7 in the middle. So we have 10 here, 10 here, 27 total. Sweet. So 27 tiles. We know what it looks like, but can we make a rule? So I'm trying to figure out how many tiles are in figure 0. I could just back myself up. There.
It'd be 4, and then it would start.
For what? Like
No, it would start at 3, and then it'd add 6 every time. So
Wouldn't it just be a straight line?
oh, so you're saying
Yeah,
this
it'd be a
is
straight
3
line of
tiles.
it'd just
accomplish that.
Figure 0, and then it would add 6, so it would add, wait.
You would add 6, yeah.
Doesn't it make it, no, I don't know.
That doesn't work.
You
We do add 6. Hazel?
I think I know what it maybe.
Oh,
Okay.
You just add 3.
No, never mind.
It has to be like that, though.
Avi?
Wait, no, never mind. Actually.
Wait, no, never mind. Alex?
Wait, so never mind. What was the question?
What's figure 0 look like?
Figure 0 is gonna have 3 tiles in it.
Yes.
Oh yeah, okay, so I know what it is.
Okay.
It's gonna be line 3.
That's what we just said, but then people were like, wait, no, that's not it.
It's right though. But then
It is
Well,
right.
yeah.
It's right. We just don't.
But
I was just
the
wondering.
problem is
if
the
it would-
pattern hasn't been.
I was just wondering if it would just add like that to each side.
no,
But then it doesn't go continuously.
Here? Who's saying here? You want to come up?
Yeah.
I assume saying here means like you're gesturing something. Feel free to change
Gesturing.
colors.
So the way you do the pattern is you add 2 here, and then on the one that's connecting both these 2 parts, you add 1 on each side here, and that's 6, and that's how you make the pattern. 3, 5, 7, 9. Add 2 here, and then 2 more there.
So Ike is saying, I like how you changed colors and you didn't draw. Ike is saying to see making figure 3, put 2 on here, put 2 on here, right? That makes our top and bottom sections. And then put 1 in here and 1 in there. And that's this and this. That would work. Now, there are multiple ways to visualize these things always, and it's brain specific. It's how your brain is wired, like literally how it's wired. So if we went backwards, I would remove these 2. Right, for those of you saying it still doesn't work, I'd remove these 2. And in the middle, I have to remove 2. Right? So I mean, somehow I'm going to take, like, okay, that one and this one, I guess. Like, it's hard to describe getting to figure 0. But, yeah, that's how we kind of end up with only 3 left. That's why we started at 1, right? It makes more sense to visualize figure 0, like, it has 3 tiles, but we're not quite sure what it looks like. Patrick?
Then wouldn't there be a space in between each tab?
Yeah, so that is a question of, like, are they all going to be interconnected? Or if we remove, like, one from there and one, like,
Well, I would say.
or does this disappear?
I think that they are connected because if you look at.
I was just about to wrap this because there's actually, like, a trick to it in a way. But you can say whatever you want. I'm not going to stop you.
The only reason I'm getting mad about it is because it does that. It would have to do that or that at first. That was confusing.
Yeah, don't draw on top of yourself in the same color.
And then you would go, and then you would have to add 2 for the next bit. So that's why it doesn't make sense for me.
It doesn't though. It does not. How the pattern works. You add the middle ones first, and then you start the outside pattern, like the.
Question. Do we all have to see it in the same manner?
No.
Do we all understand the same pattern that we're adding 6 every time?
Yeah.
Could we draw moving forward? Could we draw what we have?
Yeah.
Do you think we could draw a -1? Like figure -1. We're gonna start to draw like black holes of tiles, but could you figure out how many tiles are needed for figure -1? -3. Right? Take away 6 more. We would need, quote unquote, -3 tiles to make figure -1. So this is where this math starts to come down to, you don't always have to have a physical representation, or even if you do, you don't have to agree with each other if we agree on the math. You might see it differently, But if we agree on the math, that's what we're worried about. Hazel?
When are we going to learn calculus and this is getting closer?
You won't learn calculus this year unless you decide to do it on your own.
Are you
And
wanting
every day you do math, you're getting closer. Can I put, so this is your time now. So we have like 4 minutes left. Sorry, I did take longer than I expected, but this is a fun problem to talk about. Hazel, why do you think you want to learn calculus? Says who? Like, I'm just curious why you think that, where that's coming from. Because what? Well, yeah, I agree with all of those things. I'm just curious. I have 7th graders asking about calculus, which is not normal.